everyone, welcome to your YouTube channel where we talk all about the GATE exam. We are studying operating system and into that CPU scheduling algorithms. We have understood the first come first serve algorithm in the previous video. Here we are going to understand the shortest job first, which is also known by the name SJF, and shortest process next, that is SPN. Alright, so this algorithm we are going to understand in detail right here with the example and the common mistakes that any student do during the exam. Alright, so the criteria for this algorithm to run, to find the process to be scheduled on the CPU, what is the criteria is the burst time. By the name you can understand, out of the available process, whichever process has the smallest or the shortest burst time, that would be picked up by the CPU scheduler or the short-term scheduler for running this algorithm, okay, and allocated the CPU. And the mode of execution for this algorithm is non-preemptive mode, that is by default. Why I have mentioned here by default is because if nothing is told, if there is no way they have mentioned non-preemptive something and they are saying shortest job, then you simply have to understand it is going to run on the non-preemptive mode, because it has another variation which is the preemptive mode, which is known as SRTF, and that will be followed in the next video. We have the question right here from process 1 to process 6, their respective arrival time and their respective burst time. You all know how to find out the completion time, turnaround time and waiting time. We'll do after we schedule them. So now here on the Gantt chart, we are going to allocate CPU to the process one by one. We start from, now you see everyone, we know that the criteria is burst time, but we don't just look at the burst time. Along with the burst time, you also have to look at the ready queue. The arrival time shows the ready queue status, that what are the process right now available. So you don't have to see the minimum burst time out of all the process, because they all are not available initially. All are coming at different time. Alright, so now initially at the time 0, you see the time 0, we have two processes in the ready queue. So it's up to you. Initially at the time of learning, you might make a small ready queue status. Okay, so that you don't get confused, you can write P1 and P2 are available, none of the processes are available. Now check for these two, because we have more than one process at the same time, so we have to look at the criteria, and the criteria is burst time. So we look at the criteria 5 and 2, whichever is smaller will get chance. So which is a smaller? Number 2. Okay, so P2 gets the chance, so P2 is getting the chance. Okay, we schedule it. We schedule and we start at the time 0, and we schedule because it is non-preemptive, it will be scheduled for the complete length. What is the length? 2. So this gets finished by the time 2. So now by the time 2, who else have come? Process 3 have come. So we have process 3 and we have process 1. We have these two processes. Now look at their burst time. 5 and 1. Which is smaller? Definitely P3. Process, schedule it. For 1 burst, 2 plus 1, 3. P3 over, P3 over. Now by the time 3, who else has come? P4 has come. Okay, I'm doing it just for your convenience. If you are getting confused by this, forget about it. Alright, so we have P4 by the time 3, and among P1 and P4, so 5 and 4 is needing 3. Which is smaller? 5 and 3. Of course, 3 is small burst, so we allocate process 4 for the time 3. 3 plus 3, 6. P4 done, P4 done. Correct? I hope you're following it. Right? Now by the time 6, we have another remaining two processes coming in, P5 and P6. And if at all you get confused, you can write P along with them so that you don't confused this with the arrival time. Sometimes this also happens. These are the very frequent mistakes done by the students in any exam. Okay, particularly the GATE exam where the time is like running away. Alright, so you can just simply put the P before them to get it correct. Yeah, it is a process number and this is the arrival time. Alright, so process 4 is done. Now we have P5 and P6 also in the queue, and we have 3 processes, P1, P5, P6. We have to look at their burst time. So one is 5, one is 1 and one is 3. Which is the smallest? Of course 1. So let's take to the P5. Okay, schedule for one length, so that is 6 to 7. Okay, over. Now the next smaller from P1 and P6 is P6. Schedule it. P6 needs 3. 7 plus 3, 10. Alright, Now P6 is also over. The only process left now is P1. No other choice, correct? So process 1 for the burst 5, so 10 plus 5, 15. So this is how the CPU scheduling is going to take place. So we made use of the SJF and we scheduled the process like this. So no matter P1 was available at the initial point, but because it had higher burst time than the other process, it got the chance at the last. You can see the difference, okay? You can see the difference from first come first serve to the shortest job first. If it was FCFS, P1 would have got chance right here. But because of shortest job, it got chance here. And the smaller process got the chance beforehand. So now let's find out the completion time, turnaround time and the waiting time. Okay, so the completion time, as you just have to look at the Gantt chart. For process 1, it got finished at the time 15. Okay, so what becomes its completion time? 15. For the process 2, P2, just look at the process. Now, everyone, that is one other common mistake. Because we know process 1, so we by default go to the first column, look at its burst time, the completion time and put it right there. We don't look at the indexes. Okay, we have to look at where my P1 is because now it is not FCFS, correct? Okay, even FCFS, if P1 is arriving later, we have to check that out, alright? So now the P2 is finishing at time 2, so at time 2, P3 finished 3 at 3, P4 finish at 6, correct? P4, yeah. Then P5 finish at 7, P6 finish at 10. So after finding out the completion time for each process, it's time for the turnaround time, which you all know is nothing but then completion time minus arrival time, correct? So I will not again go there and show you the turnaround time. If you want to understand in detail, you can see the previous videos, okay? The turnaround time, the total time spent in the system by bursting and by waiting. So that is completion minus arrival, 15 minus 0. So it had spent 15 bursts in the system, okay? And you can see it had 5 bursts and it also waited for the 10 burst. It got the chance to run at time 10. So it spent 10 bursts for the waiting and 5 bursts for its execution. So it becomes 15, correct? Now 2 minus 0, that is 2. 3 minus 2, that is 1. It had to wait for nothing. 6 minus 3, 3. 7 minus 4, 3. 10 minus 5, 5. This is how we get the turnaround time, and by taking its summation and dividing by 6, you can find out the average turnaround time. The value you can find out easily by yourself, right? Now comes the waiting time. Waiting time is again nothing but then turnaround time minus the burst time. How much time we are waiting, okay? So we have turnaround time minus the burst time. 15 minus 5, it waited for 10. 2 minus 2, the process 2 had to wait for nothing because it got the chance as soon as it came. 1 minus 1, that is 0. So process 3 also had to wait for nothing because it came at time 2 and it got chance at 2 right there, okay? Now the process number 4, 3 minus 3 had to wait for 0. Again process 4 came at time 3, got scheduled at time 3, alright? Now next process 5, 3 minus 1, so that is 2, alright? So it came at time 4, process 5 came at time 4, but it got scheduled at time 6, so 6 minus 4 makes 2 waiting time, alright? Next is 4 minus 3, that is 2. Guys, you have to be very careful because exam mein problem yahi aati hai that because we are so much in a hurry, we just miss out. So it's very important to point them, okay? Look at them. Put your finger right on the chart given on your paper or on the screen wherever you can. Why? Because that makes sure that you are doing it correctly, accurately. You're not missing anything. These are the mistakes which I have observed in the past 10 years getting done by the students, and jab exam khatam hota hai, then they say, oh my god, I just missed that. I did this wrong and I lost my 2 marks, not only 2 marks, I lost my 2.66 marks because of negative marking, correct? So this is how the waiting time is, and again you can find out the average wait time by taking its summation and dividing by 6. So this is how the CPU scheduler performed the shortest job first CPU scheduling algorithm for the available processes. For practicing it more, I'll come up again very soon with practice questions in the next video. See you very soon in the next video. Till then, bye bye. Take care.